let's look at an example where we use a technique discussed in the previous video to evaluate the integral of a rational function. So in this case we're looking at the integral of x squared plus 9x plus 2 divided by x plus 1 squared times 2x minus 1. Right, so this will be our p and that will be our q. Right, and our technique says that we look at the factors of q, right, and we write down an expansion involving those factors. So here we have only linear factors. We have x plus 1 and 2x minus 1. Right? And the linear factors, right, they give you terms constant over the linear factor. Right? And we see that the linear factor x plus 1 repeats and it appears twice. So we'll have two terms for that factor. Right? We'll have an a over x plus 1 plus a b over x plus 1 squared. Right? And the other linear factor, 2x minus 1, that appears only once. So we only have one term for that. Right, so if we had a x plus 1 to the fifth, we would have, a term for x plus 1 cubed, x plus 1 to the fourth, and x plus 1 to the fifth. Right. So now the problem is to find the numerical values for a, b, and c. Right, so what we do is we multiply out this, or we add together these three fractions. Right. That means we have to put them over the same common divisor, and that common divisor is going to be q. Right. So that means we have to multiply the first term with an x plus 1 and a 2x minus 1. Right, the second one just with the 2x minus 1. And the third one with an x plus 1 squared over qx. And then now we multiply out this numerator. Right, so we'll get an a 2x squared plus x minus 1. Right, nothing happens to the second one, and we'll have c times x squared plus 2x plus 1. Again, all over q of x. Okay. And now, the last thing we do here is now we group together the like terms. Right, so what are the x squared terms? Well, we're going to have a 2a and a c. So we have 2a plus c x squared. Right, for the x terms, we'll have an ax, a 2bx, and a 2cx. So we have a plus 2b plus 2c. Now for the constants, we'll have a minus a minus b plus c. So we'll have minus a minus b plus c all over qx. Now why did we do this? Well, you'll notice that here we have p over q equals this polynomial over q. Right. So that means p has to equal this expression. Right. So we have p of x equals 2a plus c x squared plus a plus 2b plus 2cx plus the constants minus a minus b plus c. Right. So px, remember, is this polynomial x squared plus 9x plus 2. Right. And because these two are equal, and it means the coefficients for the different terms also have to be equal. Right. In other words, here we have 2a plus c x squared, and there we have 1x squared. So 2a plus c must be equal to 1. And here we have a plus 2b plus 2cx. Right. And here we have 9x. So that means a plus 2b plus 2c equals 9. And here we have a constant 2. And there we have the constant minus a minus b plus c. So we have minus a minus b plus c equals 2. Right, so we end up with three equations in three unknowns. Right, and we want to find the numerical values for a, b, and c that will satisfy all three equations simultaneously. Right, so to do that, right, well, let's label our equations. 1, 2, 3. Right, and now we'll try and eliminate the variables from the equations, right, until we are left with an equation with just one unknown in it. And then we can solve that one and substitute it back into the other equations. And so we see, well, equation 1 already contains only two unknowns, a and c, whereas equations 2 and 3, they contain all three of the unknowns. Right, so what we're going to do is we're going to take these two equations and try and eliminate b from them. Right, so that we end up with an equation just involving a and c. Right, to go with equation 1. Alright, so let's do that. So we're going to take equation 2, and we're going to add 2 times equation 3. Right, so that's going to be 2b minus 2b. Right, so we get rid of the b's. Right, so we'll have left a minus a, a 4c, and 13. Let's call that equation 4. Right, so now you see if you look at equations 1 and 4, right, they only contain a and c. Right, so if we can eliminate, say, a from one of these equations, right, we'll be left with an equation just involving c, which we can then solve. Right, so let's do that. So let's take equation 1, right, we add to it 2 times equation 4, right, because it will have 2a minus 2a, right, so 0 a's. Right, so what we're left with is 0 a's and 9c and 27 on the other side, so c is equal to 3. And so now we can just substitute this, say, back into equation 1, and that'll give us the value for a. Right, so if we substitute it back into equation 1, we get 2a plus 3 equals 1, which means a has to be minus 1. And now we can substitute the values we found for a and c back into, say, equation 3, and that'll give us the value for b. So we do just that. We substitute it into equation 3. You could use equation 2 as well, doesn't matter. Right, so then we have minus a, and a is minus 1, so we have 1 minus b, right, and c is 3, equals 1. Equals 2. Right, so we're looking at equation 3. Minus a gives you 1, we have minus b, and plus c gives you 3, equals 2. Right, which means b has to be 2. Right. So you can then write your integral I as, right, and using this decomposition with the values we found here, so we have a equals minus 1, so it's minus 1 over x plus 1, right, plus, right, b is equal to 2, so that'll be plus 2 over x plus 1 squared, right, and then c is 3, so plus 3 over 2x minus 1 dx. Right. And you can evaluate these integrals, right, as we did in the first video. Right. So let's just do it this once, right, and the remaining examples we'll do, I'll leave it to you to do them. Right. So that will give you minus ln x plus 1 minus 1 over x plus 1 plus 3 over 2 ln 2x minus 1, of course, plus c. Right. And that's how it's done. It's a bit lengthy, but in principle it's not difficult.